Thank you very much for the introduction. Yes, hello everybody, and thank you very much for joining our webinar. My name is Dietmar Streicher, just as mentioned before, and I'm working at Tebis as a product manager, and my responsibility for products at Tebis, for example, is the topic of measurement. But first, as a little introduction to those of you who do not know the Tebis company very well. Tebis is a developer of CAD/CAM software, but we do not only develop software, we also, of course, are selling it. Also internationally with the help of a lot of international subsidiaries, and we also deliver support to our customers in terms of implementation, training, and everything. So we try to give our customers a complete solution also around the software itself. Our software is used mainly in the mold making industry, but also die making. Also, part manufacturers are using our software in the sectors of mechanical engineering, aerospace, and of course, automotive. There we are very well known. If you want to have a general overview about Tebis and its products, feel free to visit our website at www.tebis.com. You will get more information there. But now to our topic, because since CAM is our daily business, we have a close contact to all our customers, and during the last 1 or 2 years, we hear more and more often some demands, not only that our CAM functions, concerning our CAM functions not only, but also for enhancements of the manufacturing process by means of measurement. For example, we had customers who told us that as an NC programmer, they want to be able to use measurement cycles, for example, at the start of an NC program, in order to check out the blank size and in order to increase safety with this check, for example, for an unattended operation of the machine, which means lights out machining. In fact, they want to make sure that there are no errors on the machine, also in times when the operator is not next to the machine for a check. Or for example, another demand was that the CAM programmers would like to be able to program a fine correction of reference points for a part rotation for the part position just before milling in order to improve the quality of the part. So we just want to make sure that the manually done setup of the blank on the machine is correct or is compensated if it is not absolutely correct. Or for example, another demand was that the CAM programmers would like to be able to perform a quality control just before the part is removed off the table, so that it can be immediately decided to perform any necessary remachining, and thereby also the quality of the part would be improved. So these ideas were in discussion, and we decided to develop a new module in our software, which allows you to put some more security in the manufacturing process by means of measurement cycles. And these measurement cycles, of course, need one prerequisite. So in order to be able to measure, of course, you need, first of all, a probe on the machine. Here are some examples of probes which can be used on milling machines. There are different producers like Renishaw, M&H, Bloom, or Heidenhain. And this is an absolutely must. You need to have such a probe on the machine, of course. Otherwise, you will not be able to do any measurement automatically from within an NC program. But these are just examples of some manufacturers. In general, you could use, for measurement cycles on the machine, you could use any probe which is able to transfer its signal, for example, by means of radio transmission. This is very common. Or from smaller machines, also a signal transmission by means of infrared beams is used. The probes may have different mechanical setups. Right now, there are 3 different technologies in the probes, which means that cheaper probes are working with mechanical sensors. Optical sensors are a way to design such a probe, or the the highest sophisticated probes, the most sensible ones are using strain gauges right now. So, but all these type of probes can be used for measurement as long as the probing signal really is transferred to the controller, and you can use the signal in the controller, for example, by means of a simple measurement cycle. So we did such a similar webinar just at the end of last year here for our German customers. And at that time, we made a little survey because, of course, it is interesting if using a probe on a machine, is this mainstream meanwhile, or is it something which is more or less still a little bit exotic? And the survey at that time showed us that 47% are using Heidenheim probes, 46% are using Renishaw probes. M&H probes are used by 19% of the customers, Bloom probes by 14%, and other probes or probes from other manufacturers have been used by 3% of the customers. So you see the total here is more than 100%. This is, of course, the reason because customers sometimes have different probes from different manufacturers on different machines. But the total availability of probes in general was about 82%. So you can see using a probe on a milling machine is no longer something exotic. It's rather mainstream, at least in the German market, as you can see here from this survey. So this is very good because there is a good infrastructure out there, and the technical prerequisites are given to use measuring cycle also within the manufacturing process. And therefore, we developed a couple of new functions. And here you can see these new functions. They are all combined within one new module, which is called measurement in the manufacturing process, the module. And the functions within this module allow you now, for example, to use a point measurement for simple offset probing or offset detection. You can use a function for circular measurement. You can use a function for an angle measurement by means of 2 points, which is the Q angle function you see here. Or you can use a measurement cycle which gives you an angle by means of the center points of 2 circles, which means 2 circular pockets or 2 circular studs, for example. You also can program a measurement task for measuring a rectangle. That might be a rectangular pocket or a rectangular stud. You will find another function in there which is called Q width, and the name already tells us this is used for measuring a width of a slot or of a ridge, for example. And last but not least, we have a function for a calibration job, the Q-calibrate function. You can use all these functions in the job manager, and you of course can combine these jobs also with milling jobs and else. Let's have a closer look on the functions in detail. So the Q-calibration job allows you with 3 different sub-strategies to do a calibration of a probe by means of a calibration sphere, for example, or alternatively by means of a calibration ring. Or you also can do a simple length calibration for your probe. And so this allows you to do a probing job, program it in the CAM software, which is a question. Why do I have to do a calibration job in the CAM software? Normally I do this on the machine on a regular basis. I have a calibration cycle there. Normally I have one, and so that's it. But it makes sense to do an NC program because the calibration also is something where you can gain accuracy, or you maybe lose some accuracy. Just imagine if you're doing a calibration on a calibration sphere. First of all, you put the sphere on the table, you take the setup in the center of the sphere manually, and then you start the calibration cycle. So what happens? You will get calibration data for your probe, of course, but this calibration data has been detected with a setup which maybe is not perfect, because the first manual touch probe operations which you did for defining the setup, they have been done with old calibration data on the controller. So it makes sense to make a little NC program to do a first calibration, then do a setup compensation on the sphere. You will measure with your first calibration data, with your beta calibration data. Now the center of the sphere again, you put the origin exactly at the center of the sphere. And now you do a recalculation, recalibration, sorry. And so now you will get better calibration data because the offset has been placed better, and you're doing one more loop for an increase in accuracy. So that's the idea behind a calibration function within a CAM program. So the point measurement function also allows you for different sub-strategies. You can do a point measurement and you can decide what is this point measurement good for. Is it used for quality checking, which means the result of the measurement will be written into a result file on the controller, a text file. Or you can decide to use the result of the point measurement, for example, for a reference point correction. Alternatively, you can decide to use it for a tool length compensation or for a tool diameter compensation or correction. So that means depending on whether you're probing in the Z direction of your probe or of your working plane, or in the X and Y direction, you can decide if this is a length or a diameter compensation for a specific tool which you have defined before. And then the tool radius or the tool diameter on the controller in the tool table of the controller will be changed. And so this allows you to integrate the offset into the tool data, and for example, to use this for a more precise finishing operation after the measurement. The Q-circle function is set up in a similar way, but here, of course, we are measuring a circle. It can be a pin or a bore. Of course, we can also measure only part of a circle, like an arc measurement. It doesn't need to be a full circle. And also these measurement results can be used then for quality checking. The measurement results will be written into a file on the controller again. Or you can use the measurement result for a reference point correction. In this case, the center point of the circle will be used for a reference point correction in X and Y. Or as a third step, you can choose this function to be handled in combination with a tool diameter correction, which means that the detected diameter, the measured diameter of your circle, or the offset of this diameter, the measured offset, will be written as an offset value into the tool table of your machine. Then the Q-angle version, the Q-angle function allows you to do a measurement with 2 points. The 2 points represent a line then, and this line, of course, has a specific angle in reference to the x-axis of your working plane, and this angle will be determined as a measurement result. And you can use this angle for a quality check, of course, or for a reference point correction. For example, for compensating a rotation of the part on the table. Another version of angle measurement is the function which allows you to measure an angle by means of 2 circles. This can be 2 studs or 2 circular pockets. Also here, it's the same as with the point angle measurement. You can use the result for a quality check or for a reference point correction. Also with this technique, you can define the rotation of a part on the table, for example, and you can use this as a z-axis offset if you have a rotary table on the machine, or as a part rotation value in the setup of the machine, so that this can be compensated. The correct function allows you to measure a rectangle. Also, this can be a rectangular pocket as well as a rectangular pin. And also here you can do a quality check or a reference point correction with the data, with the measured data. The queue width job allows you a slot or rib measurement. You can determine the width of the slot or of the rib, and you can write the result into a quality check result file, or alternatively, you can use the result for a reference point correction. In this case, the center of the rod and slot or the rib will be used as the value for the measurement. All these jobs can be combined in the job manager of Tebis. The measurement jobs are fully integrated there, which means that you can combine measurement jobs, milling jobs, turning jobs, or trimming jobs, for example, in one single NC program. And of course, you can do the simulation as well, which is very important. You can do the collision check with all these toolpaths, also with the measurement toolpaths. And you can use also these type of jobs for off-screen calculation if you want to let Tebis do the work in the background. Let us have a little closer look in the function details now. In the function itself, well, the user interface will be very familiar for everybody who is working with Tebis. The layout of the menus is pretty much the same as it is for the CAM cycles, which we have, the CAM functions. But there's one special thing about the measurement functions. In the measurement functions, we have two possible sets or entries for the cycle calculation, standard and extended. And this is very important, in fact, a little switch, but which has a very important functionality behind it. If you decide to calculate the toolpaths for these measurement operations in the setting for standard, then this means that the Tebis-based output for the control measurement cycles is activated. That means nothing else that the post-processor which you're going to use, if it is enhanced to handle these measurement cycles, is going to print measurement cycles which the controller natively has into the NC program. That means for a Heidenhain controller, for example, you will get directly touch probe cycles in your NC program, for example. But we also added an extended version for NC output. And this extended version in the background is using the Renishaw API. So you see here, we have decided to start a partnership with the company Renishaw, and they have a very nice product, which is called Productivity Plus, which is usable as a standalone software, but which has the big benefit. It has an API, an advanced programming interface, which we have added into our software. And this allows you in the background to calculate measurement cycles by means of that software. And this allows us again to do some enhanced measurement output also for such controllers which do not have native measurement cycles. A FANA controller, for example, Mitsubishi, Mazak, they all do not have measurement cycles in such an extent as an Heidenhain controller, for example. And even Heidenhain controller, at least older ones, do not have measurement cycles for all possible functions which we offer. So it makes sense to find a solution which can be used directly on the controller as a runnable NC program to handle all this stuff of measurement functions. And we decided to do this cooperation with Renishaw here. And our first results here are very, very good. We are very happy that we used this because Renishaw allows us to do measurement operations also on the controllers listed here, as you see. And a lot of them do not have native cycles for measurement operations. But with by means of this Renishaw solution, you will get an NC output, which is shown here, for example, in which you will not only get a main program, which contains cycle calls, milling operations, and every stuff which you need for a complete NC program. It will also deliver you a subset of subprograms, and these subprograms are exactly the subprograms which you are going to need for the measurement operation within the main program. So you will get one package, one container, which can be loaded to the controller, can be started, and all the measurement operation is done then on the machine, because the Renishaw tools and subprograms have the capability to handle the touch probe signal, to allow movement with the touch probe in a protected way, for example, so that the probe will stop immediately if it touches somewhere where it is not planned to touch, something like this. So all this technique is hidden within these subprograms. And that's a pretty cool solution, I think. Let's have a look on the details of our menus in the measurement functions. As you can see, everybody who is working with Tebis already, he will recognize that the setup of the function is pretty much the same standard or strategy, the same layout as you're familiar with from the milling functions already. You have a bar for sub-strategies, and these sub-strategies you are going to define what is the purpose of the machine for the machine results. Is it going to be used as a quality control? Is it going to be used as a setup compensation or as a tool data compensation? Then you have a block where you can define the details about how the measurement path is going to be generated. You have a block where you can define what is relevant for the measurement results. And the last block is the topic about a check if the measured point are reasonable. The probe safety check here, if it is used, will allow you to check every programmed point for measurement. If there is a second point of touch for the probe sphere, if you're programming too deep into a corner, for example, not only the point which you want to probe is okay for measurement, but the sphere is going to touch on a second flank of your part, and this would be detected here during the calculation of the tool path already. So these measurement functions also can handle different tolerances. Of course, we are supporting the length tolerance, diameter tolerance, and angular tolerance, which you can edit in the functions. And for circles and rectangles, we have the position tolerance as well, because this is something different from the length or diameter tolerance, of course. So you can edit these tolerance values individually within the measurement jobs. So, and also I want to show you the results of a second survey which we did last time, because we asked the attendees of that webinar if this is a real scenario for problems which might be checked before they really become a problem by means of measurement cycles. We asked the customers if there was already the situation in their company that a blank was clamped incorrectly and the error was not detected until after starting machining. Oops, sorry. And 61% answered yes, this happened already in our company. And the second problem was there an incompletely machined part which has been removed prior to the error has been detected. Also to this, 57% answered yes, this happened already. And as you know, if you have a more complex part, it might be really difficult to recognize if the last little edge or corner, if the finishing job has really been programmed there, or has it been forgotten. If there are 2/10 of a millimeter material left, you might not really recognize this in time. And the third question was, is at least one of these problems, has at least one of these problems been happening in your company? And 71% said yes, one of these has shown up. So you see, these scenarios are pretty much common. And it would be, I think, really helpful for a lot of people if they have another tool available to minimize these risks. So if you are doing such a measurement on the machine, especially if you're doing the quality check, then we also invented a new function which is called rule and see. Rule and see means rule geometries can be documented here. A measurement protocol can be done with this function. And with this function, you are allowed to read back the measurement result file, which is written on the controller, which is a text file, in fact. But reading a text file sometimes is not so easy. You don't have the reference to the part. Where was the point at the part or the circle? If you have more complex measurements with a lot of circles and measurement tasks in it, it will be more complex. And so we allow the customer to read back these results, and which then can be visualized in the software. Here you can see an example for some circular measurements and point measurement. A rectangle has been measured here. So you will get an interactive, a visual representation of your measurement results with the measured position, the tolerance values, and of course the deviations which you have. And if you not only want this to check this in the software itself, of course you can also generate a documentation, a PDF file, for example, in which you then will see the detailed values of the position, target position, the measured position, and the deviations, and the actual the status. Is it within the tolerance or not? So all this, of course, is possible for the different measurement jobs and will give you the benefit of a better visual presentation of the results in reference to the part. It allows you to do a documentation of the part's quality just before you put it off the table, for example. And it allows you also the reduction of errors, because now you really have a tool to see if you are out of tolerance somewhere. And this, of course, hopefully will give you an increased productivity. But let us have a look in a little video about how this works. I have made a little video on our DMU ATP machine, and I'm just and within this video you see now how tool change is done, and the probe is now loaded, and here we have a part which we have produced for a measurement exhibition or an exhibition, and we are of course using these parts also for testing our own software. And here you can see the simulation, which is working as well in Tebis, and here the real movement of the machine for a circle measurement in this circular pocket here. With the tilted tool, of course, now the tilting direction is going to change. Simulation and collision check has been okay. Now we are going to measure this the width of this ridge here on different positions. And of course, this is a pretty much 5-axis part, but you can see also these pockets. It's not a regular geometry, but still it's a pocket. And also here you can do, for example, an offset measurement with point measurements in order to detect the offset on the material. So that was the presentation, and here you can see as a last thing the output of the results, and of course in a PDF file also the tabular version of the measurement results. So let us close the video and let's go back to my presentation. Here we go. So of course the benefits are you can use this for a check of a blank size, for example. If you want to do a preparatory measurement before machining, you can check the blank orientation with it. You can decide to stop the program on an error detection immediately. That's very important, because if you recognize the blank has the wrong size compared to the theoretical blank size which you have used in the CAM system, then the machine should stop. You don't want to have an operation where the blank is too small and you're milling just chips for nothing. And of course, this may prevent machine damage, and it prevents also manufacturing of scrap, as you can say. So another benefit, of course, for if you want to use the measurement functions in a preparatory measurement before machining, is that you can make a fine adjustment of your reference points as far as the part concentration is concerned, but as well as far as the reference point's position is concerned. Also, this, of course, increases quality. And last but not least, if you do measurement checks after the machining, you can do a part checking in order to control measurement of ruled geometries for precision and dimensions, and you can detect areas with a residual stock, for example, omitted finishing areas, for example, and of course you can do a documentation before the part is unclamped. So this increases the quality and the speed of delivery for the customer, definitely. And this is, I think, one of the key benefits. Some general information. This module is available from version 4.0 release 9 on in Tebis. So our current release contains this module. And if you have the license for it, if you want to get that, you can use it. And the pre-requirements, of course, is that you need a virtual machine. This is something which you need to know, because the virtual machine only allows you to handle all the necessary data concerning the setups of the part. And the second point is you need a new post-processor, which is set up with our simulator-based post-processor architecture. A lot of customers do have this already. If you have that, then these post-processors can be enhanced, and the measurement cycle output can be added in these posts, of course. So one or two last slides just as an example of the scope of this module. Here you can see an example of part alignment cycles from Heidenhain. Heidenhain has a lot of measurement cycles by standard, and all these cycles, for example, now can be supported with these measurement functions for a part setup. Or alternatively, if you don't have a Heidenhain controller, but a FANUC, for example, we can use the Technische solution as well, and also the functionality of such cycles is available and principally on the FANUC controller. Here is a second example about checking routines, measurement cycles for checking the part. Of course, they are supported as well. Also, again, you can decide whether to use the standard cycles on the controller if they are available, or you can use the Technische cycle output, which allows you, even if the controller doesn't have such graphical programmable measurement cycles, you still have an enhancement by this module so that you can run such measurement cycle programs. In total, we are able to support 25 different measurement cycles right now. If we compare this with the Heidenhain cycle scope. So this is quite a powerful thing, I think, and should be very helpful in the future for our customers within the manufacturing process to put more quality and more safety into this process. And so now I'm also at the end of my presentation. I'm saying thank you very much for your interest, and I hope that it was interesting for you. If you have any questions, please do not hesitate. You can edit the questions into the questions tab, I think it is called, in the menu of the GoToWebinar. And so questions. There are no questions up to now, as I can see. Was it everything clear so far? Well, one question which I always get if I'm in contact with customers directly is really that they are concerned about, can I use the probe which I do have on the machine? And as I mentioned in the beginning, that was the reason why I took a little bit of broader explanation to that. The main point is really if you have a probe in the machine and if you're using it, for example, for manual setup of the part already, that you really get a touch signal to the controller, and the controller stops automatically when the probe is, how do you say in English, deviated. Then there is a connection between probe and controller. It's something different if you have such a probe which only gives you a light as soon as there is a touch to the part, and you should stop the machine manually. Then you do not have a complete connection between probe and controller. So this is the main topic which you have to check as a prerequisite. Okay, I see there is a question. Is everything combinable? Yes, it is. Combinable, I think this means can different types of jobs be combined? Yes, of course, you can do a measurement first for to be sure that the right blank is set up on the table in the right size. If the blank has the right size, then you can program some measurement jobs in order to do a fine compensation of the setup, just in case that the setup as the manually probed setup is not absolutely correct. And after that, you can program your milling jobs, roughing, finishing jobs, everything, and you can put this into one NC program if you want. That's absolutely no problem. So are there any more questions? I'm just gonna wait a little bit if anybody is sending another question. Well, not really. Okay, so well, from my side, I hope that the presentation was interesting to you. I am very happy that we have such a big number of attendees, and I just can recommend, if you're interested in this, to have a closer look. Get in contact with your sales representative who is next to you at your local subsidiary internationally, and let you give some more information about this if you need it. So thank you very much from my side. I'm very happy that I was able to present you this new development, this new module, and there's nothing more left than to wish you a nice day and a nice time until maybe our next webinar or wherever we may meet. Thank you very much.